Picture this. You're a database administrator or a DevOps engineer with experience self-managing databases on VMs. From time to time throughout the year, you're called on to tune up your database. Perhaps the application team has noticed that there's a performance issue that needs to be fixed on the latest database minor version. Or maybe the security team has come calling to let you know that the operating system that you're using for those databases has a vulnerability that needs to get patched. Now, these tasks are tedious, but you know how to take care of them in your self-managed databases. Well, now you hear that you're going to be managing databases in Cloud SQL. And you're excited, but you've never used a managed database service before. How are you going to keep those databases up to date? My name is Akhil, and I'm one of the product managers here at Cloud SQL. I'm going to talk to you about three things today. First, we're going to discuss what is Cloud SQL maintenance and what happens behind the scenes when Google Cloud performs maintenance for you on those Cloud SQL instances. Next, we're going to talk about how you can manage maintenance to minimize any application impacts that might occur because of maintenance. And finally, we're going to discuss how you can upgrade your database major version. And I'm really excited. I have an announcement to share with you at the end of our session here. First, Google Cloud SQL is Google Cloud's fully managed database service for MySQL, Postgres, and SQL Server instances. Cloud SQL takes care of the routineness of managing your database for you. That's things like setting up replication, provisioning the database, setting up monitoring, logging, taking backups, and yes, maintenance, so that you can focus on those activities that are most important to make your application successful and your users happy. If you've managed databases before, you know that keeping your system up to date is a chore. There is so much to take care of, from bumping up the database minor version, to consistently patching your operating system, to scanning for new vulnerabilities and making sure that you've taken care of those too. There is so much to do, and while it might not be glorious, it's super important, because if you don't do these things, there's no way for you to be sure that your system is secure and it's performing properly. Well, I have some good news for you, which is that Cloud SQL takes care of these system updates for you. Cloud SQL performs these system updates on a regular basis, and specifically, there are three kinds of updates that we manage for you. First, hardware updates are things like swapping out a defective machine host or replacing an old disk to make sure that the components that underlie your database are in tip-top shape. Google Cloud has advanced live migration technology, which ensures that these updates can be performed without interrupting your application. Next, Google Cloud takes care of online updates for you. These are software updates to the service agents that support your database engine, things like logging and monitoring. Again, these are performed without interrupting your application. Lastly, Cloud SQL takes care of maintenance for you. Those are changes and updates to the database engine or the operating system. Now, maintenance does require a restart, which means some downtime for your instance. Now, downtime is never ideal. So is maintenance really actually critical? The answer is absolutely. And it doesn't matter where you host your database. Maintenance is super important to make sure that your database stays healthy. Cloud SQL performs maintenance once every few months, and when there's a maintenance event, you can count on three things happening with your database. The first is we'll deliver new features to you. That's things like plugins and extensions, new query monitoring software, and new security tools, so that you can have access to the latest and greatest there is out there. Next, we perform operating system patches to make sure that any new vulnerabilities that are detected on your operating system are patched so we can protect your instance from any new exploits. Lastly, we take care of minor version upgrades for you. The database engine developer is always releasing new performance fixes and bug fixes for you, and we uptake those and release them to you so that you have the latest software from them as well. What happens behind the scenes when a maintenance event occurs? This is a diagram of what your application speaking to your database normally looks like. The application sends traffic to a static IP address, which forwards that traffic to a VM. The VM is hosting the database engine software as well as several supporting service agents. Database activity is written from the VM to the disk, where it's stored durably. When a maintenance event begins, Cloud SQL spins up an updated VM in the background while your application is still being served by the original VM. That updated VM has the latest software for the database engine as well as the operating system. When it's time for maintenance to start, we go ahead and shut down the original database engine on the original VM. Now we need to do this because we're going to be moving the disk from the original VM to the updated VM. Once that's complete, we also will reconfigure the static IP address to forward new traffic to the updated VM. We then start up the database engine on the updated VM on that disk, and once that completes, your application is up and running, being served by the new updated VM with the latest maintenance version and the latest operating system. Once all that's complete, we go ahead and clean out that old infrastructure for you as well. Database maintenance is engineered to reduce application impacts, to make sure that we can get you back up and running as soon as possible. There are no changes in IP address, name, or any database settings caused by maintenance. In fact, to your application, the fact that your database is running on an updated VM is totally transparent to it. There's also no loss of data because we use a shared disk failover approach. Any transactions that are committed to the disk prior to maintenance, you can be sure those will be available to you as soon as maintenance is complete. Nevertheless, there are still some impacts that you should be aware of with respect to maintenance. First, the moment that we fail over that disk to the updated VM, existing connections do get dropped. In addition, there is a brief downtime that is incurred with respect to maintenance. Cloud SQL has reduced maintenance downtime by 80% since 2020, and today, downtime for Postgres instances is less than 30 seconds, MySQL instances less than 60 seconds, and SQL Server instances less than 120 seconds typically. Of course, Cloud SQL is always investing in continuing to make improvements to maintenance downtime. Lastly, the database cache is cycled out with the original VM, so the cache is going to be clear on the updated VM once maintenance completes. There are several things that you can do to manage the impacts with respect to maintenance and minimize disruption for your application. In general, we highlight three things. The first thing we recommend is that you go ahead and schedule maintenance to occur in off-peak times for your application. And you can do so with a few settings we offer. First, you can designate a weekly 1 hour long interval called a maintenance window to govern when Cloud SQL will actually schedule maintenance updates for your instance. We recommend that you position these at the time during the week when activity is typically at its lowest. You can also designate a block of up to 90 days called the deny maintenance period, which is a time during the year when Cloud SQL will forego scheduling maintenance updates for your instance altogether. For example, if you have a busy season where you have a lot of business activity, you may want to position that deny maintenance period during the block of days that coincides with that busy period. Now, I should mention that if at any point Cloud SQL schedules maintenance at a time that's inconvenient for you, you can always reschedule that maintenance event and defer it by up to a week. And if that doesn't work for you, you can use the deny maintenance feature to overlap with the original time that maintenance is scheduled and effectively cancel it. Later on, when you're ready to catch up to the latest maintenance version and take care of those latest features, operating system updates, and other improvements in your software, you can use our new self-service maintenance feature to coordinate maintenance at a time that works better for you. The second thing that we recommend you do is to validate new maintenance updates in staging first. And you can do so using Cloud SQL's order of update setting. For example, if you set your staging instances to earlier and your production instances to later, when it's time for Cloud SQL to schedule maintenance, we'll schedule those staging instances for you a week before the production instances. That gives you a week to go ahead and test the new maintenance update on staging, validate everything works as expected, and so you're ready when that maintenance update rolls out to your production environment. Finally, we recommend that you design your application to be resilient to maintenance. Whenever you're running applications in the cloud, there's always a chance of these transient errors. And some of the impacts of maintenance, like the brief downtime that's incurred or the dropped connections, are other examples of these transient errors. So you'll want to make sure your system is resilient to these. You can also do things like institute a connection pooler between your application and the database, which allows for you to preserve those application connections when the database goes down. The connection pooler can also do things like help ramp up the existing connections, the new connections to your existing database after maintenance completes to take care of some of the load off of that application. And finally, we recommend that you take a look at reducing those long-running transactions. Limiting those long-running transactions, especially when maintenance is scheduled, can make sure that we can recover your instance as fast as possible and get you back up and running as soon as we can. I hope by now it's clear that Cloud SQL takes care of most updates for you. Now, there's still a class of special updates that we call configuration updates that you'll need to manage. Here are some examples of configuration updates. Instance resizes are moments when you will increase the number of vCPUs on your instance or increase the amount of gigabytes of memory on your instance. And this may happen as the performance of your database needs to scale up as the amount of activity increases on that database instance. We also have things like flag updates. As your workload pattern changes over time, you may need to adjust the settings for your database instance, and you can do so by updating the flags on your Cloud SQL instance. Lastly, we have major version upgrades, which is when you upgrade your database's major version to the latest so that you can take advantage of new features and other benefits associated with that latest version of software. Let's talk for a moment about major version upgrades. As we've already discussed, Cloud SQL takes care of database minor version upgrades for you during routine maintenance. But if you want to perform a major version upgrade to benefit from cutting-edge features or performance boosts or other fixes and goodness, you'll need to perform a major version upgrade. I'm excited to announce today that Cloud SQL is rolling out preview support for in-place upgrades for Postgres and SQL Server with support for MySQL coming soon. With in-place upgrades, you can upgrade your database in just a few minutes with a single command. When you perform an in-place upgrade, Cloud SQL keeps things simple for you. We take care of maintaining the database's IP address, the user data, the settings, so that we can minimize the amount of effort that you need to expend related to the in-place upgrade. We also take care of the tedious tasks for you. That's things like backing up your database before and after the upgrade, updating your instance's configuration data, and running some of those pre-compatibility checks. We also will take care of automatically rolling back your database in the event that anything were to go wrong so that you can recover as quickly as possible. When compared to migration-based upgrades, in-place upgrades are faster, they're more reliable, and they're simpler for you to take care of. Why don't we go ahead and run through an example together? Let's say you work at a company called BuyLots, and you're running a database called InventoryDB. Now, InventoryDB uses Postgres 9.6, and when you were looking through the Postgres documentation, you saw that Postgres 14 offers much better performance with respect to managing connections. And you're really excited because InventoryDB is a connection-heavy database. You go to the Cloud SQL console, and the first thing that you decide to do is clone InventoryDB because you want to do a dry run of the upgrade to make sure everything runs smoothly before actually upgrading the production instance. Once you've cloned InventoryDB, you head to Inventory DB Clones Overview page, and you click the Edit button. This is the screen that you'll see. You'll notice beside the database version, there's a new Upgrade button. You click that button, and Cloud SQL will take you to a screen where we'll prompt you to tell us which database version you want to upgrade to. You click the drop-down menu and select Postgres 14, and when you continue, you're taken to a screen where we can ask you to confirm you'd like to upgrade from Postgres 9.6 to Postgres 14. You type in Inventory DB Clone's name to confirm that you'd like to start the upgrade. Next, you're taken to the Instances Overview page, where you can monitor the upgrade progress in real time. You take a moment away, maybe you go to the daily Wordle and crush that in 3 guesses. When you come back a few minutes later, your database is upgraded to Postgres 14. You run some acceptance tests and you're thrilled with the performance of Postgres 14 when it comes to managing those connections. Now you're all ready and squared away to actually schedule the upgrade for your production database instance. Here we are. Now you're an expert in maintenance and upgrades. We've talked a little bit about the importance of Cloud SQL maintenance and what happens behind the scenes when maintenance is performed. We've discussed how you can manage maintenance and minimize any application impacts associated with Cloud SQL maintenance. And finally, we did a demo of in-place upgrades and showed you how you can use in-place upgrades to upgrade your database to the latest major version. We recommend that you try using out our maintenance settings next. You can go to this link on the slide to learn more about those maintenance settings we covered in this session. We also would love for you to stay tuned to learn more about in-place upgrades when that feature finishes rolling out preview support for Postgres and SQL Server. The best way to do that is to subscribe to our release notes. We'll be sure to let you know in our release notes as soon as that feature is available for you to try out. Thank you so much for your time. Ta-ta for now.